Hey guys, so this is problem 83, remove duplicates from sorted list, right? It is an easy problem, and let's start with the problem statement. So given the head of a sorted list, so first of all, the thing that has to be mentioned here, that is mentioned here, is that the list is going to be a sorted list. So so delete all the duplicates such that each element appears only once, right? So look at the question, look at the solution part. So you are given with the list node head, so a list is there whose head is given to you as a parameter of this function. And what do you have to return? So you have to return the very head of the new list that you'll be making, right? New list, or maybe you can manipulate the same list also. That is up to you, of course. In our case, we are going to manipulate the same list, right, using some pointers or something like that. So let's discuss this approach first so that you'll get a very clear glimpse of the question. So see, suppose this is our list, okay, and what do we have to return? We have to return something of this sort, that the element whichever are repeated, only one occurrence of such element will be considered. Okay, so 1 is repeated twice, so only once we have to count it. Again, 2 is repeated 4 times, so only one time it will be counted, right? 3 is only one time, so in the result also it will be one time. Then 4 is repeated twice, so one occurrence of 4, and similarly 5 is one time, so in our final list also it will be one time. So this final list is what we have to basically return, right? So what will be the approach that we'll be using? Let's consider that at the moment. Okay, so let's remove this first. Okay, so right now we are given with this head, है ना? So this head has been given to us, the very initial node. So we are going to use two pointers here. First pointer will be our previous pointer, and the second will be current. Previous will tell us the part of the list which already has been the rules have been applied to, and the current pointer basically will tell that what is the current node you're working on or you're checking the conditions for, right? So these two pointers are what we're going to use here. So initially I'll make the pointers to point to very first node, right? So previous is also pointing here and current is also pointing here. Because the list is sorted, so one thing is very clear, that if there is a repetition, then that has to be the subsequent element only. It will not happen that two of the ones are here and then after the list also one is here. It will not happen, right? All the occurrences will be together. So if 2 is repeated, every occurrence will be the subsequent occurrence only. It will not happen that 2 times 2 is appearing at the first part of the list and then other 2s are appearing in the last segment of the list. It will not happen, right? Because they are sorted already. So this thing is clear. Now we can move on to the implementation or the logic that we are going to use in this question, right? So current and previous both are pointing to the first node, right? The condition that we have to check here is that if current dot next dot well is equals to current dot well or not. Based on this condition, we'll be applying some rules here, right? So first of all, we'll check. So for first current, we'll check the first node's value, that is 1. The second node, that is current dot next dot val, is also equals to 1. This time this is equal. So what do we have to do when the subsequent nodes are equal? We have to just move the current pointer, right? We'll not move the previous, we'll move current, right? Again, we'll check for the condition if they're equal or not. This time they're not equal, right? That is 1 and 2 are not equal. So first thing is that whenever the current dot next dot val and current dot val are equal, we have to loop, right? We have to use a loop to check that how many such elements are there. So just after finishing this loop, the arrangement that we'll be making here is that we'll be setting previous, right? So I'll use a different color. So we'll be setting previous dot next to be current dot next, right? So here, after finishing the loop, we'll be making some adjustments also. That will be previous dot next should be equals to current dot next, right? So this link will be set up here, and then we'll say, so this link is gone now, and then we'll say that current dot next, not current dot next, but current is equals to current dot next. So now current will point here. Okay, again we'll check for the condition. So this if is now over. So first we checked for the if condition. If it is true, then we'll loop through it, like how many such elements are there that are repeated. So if there are more than one, more than two of the ones, then we'll loop through it, that how many such elements are there. We'll cover them all, and after covering them all, then we'll make such type of rearrangements, right, of the links. Then again we'll start with the same condition, that are the current dot next dot val, that is 2, is it equals to current dot val, that is 2? Yes, it is equal. So again you have to loop through it, right? So change current to current dot next, and then again check. So right now we are just looping through it, na? That how many such elements are there which are repeated. So again we'll check for current and current dot next. Again they are equal, to just move this current. Again you have to check for current, you have to check for current dot next and such things. So these two values are also equal, so you have to move this current. Again you have to check. So this time they are not equal. So whenever these are not equal, then you cannot basically you cannot move this current. You have to stop here, and now you have to again make the readjustment. So the previous right now was here, right? Previous basically at the moment was here, right? We have changed the previous. I have not written it, but now previous is also equals to previous dot next. This step has to be followed. So previous at the moment is here, right? And again the same three statements have to be executed. That is, previous dot next equals to current dot next. So previous dot next is equals to current dot next. Current is equals to current next. So now current will point here, and previous equals to previous next. So previous is also here, right? Again you have to start comparing. So this time we compared current and current next. They were not equal. Whenever they are not equal, you have to just execute simple things, that are current equals to current next, and previous is equals to current. So they'll be pointing to on the same node. So previous is also there, and current is also here. Again they are equal, so you have to loop through the elements which are equal, right? So current will be moved to 4. Again you will be comparing. They are not equal, you will stop here. So right now current is here, previous is here. Now what we have to do is these three statements. So previous dot next is equals to current dot next, so this. Then current is equals to current next, so current will come here. And previous equals to previous next, that is previous is also here now. And of course now as the list is over, so we can stop. So after looking at the list, you can make one thing very so you can basically now return the head, which is basically is going to be the same head, but now because of this readjustment of the links, the new list would look something like this. That is, 1 is here, then this rearrangement of the link has been made. So now 2 will come next, and after 2 this link was removed and the new link was set up, that is 3. So 3 will come here, then after 3 4, and you can see that after this link, this new link was formed, this was removed, so directly 5 is there. This is our new list. So the same thing, if you'll come in the solution part wherein I'll be coding, you'll see that how simple implementation will be there. If you want to try, you can also try by pausing this video, right? Because you have got a inside key how this problem has to be solved, so you can try it by yourself also. Otherwise I'm going to implement it right now, so you can check for it. So first of all, we have to need these 2 pointers, right? Those were, first one was current, which was pointing to head again, and second pointer was list node previous, which was also pointing to head, right? These 2 pointer we need. And afterwards, what do we need now? So basically a loop which will be looping on whole of the list. So while head is not equals to null, until then we can check for some conditions. The first condition was this, that is head if, so we are traversing using current, so we cannot use head, of course. So until current is not equals to null, till then we have to loop through the list, right? So the first condition that we are checking is that if current dot next is not equals to null. So this is a edge case, right? And if it is not equals to null, then we have to check for the values. If current dot val is equals to current dot next dot val, so agar ye condition, if it is satisfied, then what do we have to do? We have to loop through the list until we found a distinct element. So while the same condition we can use for loop also, right? So while this condition is being followed, until then what we have to do is that we have to move this current pointer to current dot next. So that's it. So current is equals to current dot next, right? A simple increment is being done here, and just after that thing is finished, then we can set our previous dot next to current dot next, and the secondary adjustment will be that current is equals to current dot next, and now you can move your previous to your current too, right? And if this is not the case, right, if this is not the case, that is the values are not equal, then what do we have to do? Then you can just simply say that current is equals to previous dot next, or you can say that current is equals to previous, wherein previous has been shifted to previous next. So something like this, right? And that's it. So the whole loop will work until you are not getting current as your null, and after getting that you can return the head, right, which will be same as the previous head. So yahan se we will be returning our head, and that's it. Now we will submit the code. Let's see if some test cases are there which are not following it. So all the test cases are following it, of course. So yeah, that's it. So yes. So basically, after doing this problem, you can jump on to the next problem, that is problem number 82, which is also the same thing, right? We have just solved it in some other video also, so you can take reference from there. So you can start solving it by yourself first, and afterwards you can take reference from that video. I'll show you the problem number also. So it is problem 82, which you can try, right? So it is also following the same thing, just with a few changes. So try for these two problems. I hope that you understood the concept well. If you do so, please check out for other videos also. So thank you.